214 years ago, in the dead of winter, the ground beneath a small Missouri town did something no earthquake in recorded American history has done before or since. It rang church bells in Boston, 1,000 miles away. It knocked down chimneys in Cincinnati and St. Louis. It made the Mississippi River, one of the largest rivers on the entire continent, briefly flow backward. And it happened not in California, not along any of the plate boundaries most Americans associate with earthquake risk, but directly beneath the heart of the country. In a stretch of Missouri, Arkansas, Tennessee, and Kentucky, most people have never once considered seismically dangerous. Today, roughly 200 small earthquakes still shake this exact same zone every single year, most too small to feel, monitored around the clock by a dense network of seismometers. Few people even know exists, and the U.S. Geological Survey's official position, built on decades of research from federal, university, and state scientists, remains unambiguous. This fault system still poses a significant ongoing hazard to 15 million people, and because science genuinely cannot predict when its next major rupture will occur, the only responsible approach left is preparedness. Today, we're breaking down exactly what the new Madrid Seismic Zone is, why it produced some of the most powerful earthquakes in American history, why scientists still don't fully understand what causes it to rupture at all, and what the actual current data says about the risk it still carries. No exaggeration, just what the USGS and the researchers who study this fault system directly are confirming. If you want to keep learning about the seismic hazards most people don't know exist, subscribe and turn on notifications. A thumbs up helps this critical information reach more people who live within reach of this specific fault system. Let's get into it. Let's start with what actually happened here in the winter of 1811 and 1812, because understanding the scale of that historic event is genuinely essential to understanding why this fault system still commands this level of serious, sustained scientific attention today. Between December 1811 and February 1812, the new Madrid Seismic Zone produced 3 of the most powerful earthquakes in United States history, all within a single winter. The first struck in the pre-dawn hours of December 16th, waking 400 terrified residents in the small town of New Madrid, Missouri, with violent shaking and what witnesses described as a tremendous roar. The first shock woke people 1,000 miles away. Church bells rang in Boston. Chimneys collapsed in Cincinnati and St. Louis. Witnesses reported seeing actual ground waves rolling visibly across the surface of the earth, and thousands of aftershocks followed in the days and weeks after. A second major earthquake struck weeks later, destroying the town of New Madrid outright, triggering massive landslides and permanently altering the landscape, including the formation of Reelfoot Lake, which still exists in northwestern Tennessee today, created directly by the ground sinking during that specific earthquake. A third and final earthquake, widely regarded as the most powerful of the entire sequence, was felt as far away as Quebec and Florida, and eyewitnesses reported the Mississippi River itself temporarily reversed its own flow. It's worth understanding exactly why an earthquake striking this specific location produced such an extraordinarily wide-felt area, because it's genuinely different from how earthquakes typically behave along the West Coast fault systems most Americans are more familiar with. According to detailed geological analysis, the new Madrid Seismic Zone is what's called an intraplate seismic zone, meaning it sits in the middle of the North American tectonic plate, not at its edge. That distinction matters enormously. California's fault systems, the San Andreas, the Hayward, and others we've covered extensively in previous coverage, sit directly along the boundary where the Pacific and North American plates grind against each other, and the fractured, jointed rock characteristic of an active plate boundary tends to absorb and dampen seismic energy relatively quickly as it radiates outward from an earthquake's epicenter. The central United States sits atop considerably older, colder, and more rigid continental crust, rock that transmits seismic energy with dramatically less resistance. That's precisely why a magnitude 7.7 earthquake occurring within the new Madrid zone would, according to that same analysis, affect an area roughly 20 times larger than an equivalent magnitude 7.7 earthquake would. Affecting California purely because of the fundamentally different rock structure the seismic waves are traveling through. Now here's a genuinely fascinating and genuinely humbling admission that comes directly from the U.S. Geological Survey itself, worth understanding clearly before going any further into this story. When asked directly what actually causes earthquakes at New Madrid, the USGS's own official answer is refreshingly honest. No one knows what causes New Madrid earthquakes, though there are ideas currently being researched. That's a genuinely remarkable statement for the nation's premier earthquake research agency to make about one of the most significant seismic hazards in the entire country. Unlike California's fault systems, where the underlying mechanism, 2 tectonic plates grinding directly against each other, is well understood and extensively documented. The New Madrid zone sits in the middle of a single, supposedly stable tectonic plate. an area that, by the basic logic of plate tectonics, shouldn't be producing significant earthquakes at all. The leading theory researchers are currently investigating involves an ancient, failed rift zone, a place where the North American continent very nearly split apart roughly 500 million years ago before that rifting process stalled and reversed, leaving behind a zone of weakened, fractured rock buried deep beneath the surface, rock that apparently remains capable of rupturing under the right conditions, even hundreds of millions of years. Later, long after the original rifting forces that created it have disappeared. Let's talk about the geographic footprint of this fault system, because it's genuinely larger and more consequential than most people realize. According to detailed mapping of the zone, the new Madrid Seismic Zone consists of a roughly 150-mile-long series of interconnected faults across the central United States, generally following the path of Interstate 55 in a zigzag pattern through communities including Blytheville, Arkansas, crossing 5 separate state lines, and cutting across the Mississippi River itself in 3 distinct places. The zone directly threatens major population centers, including Memphis, Tennessee, St. Louis, Missouri, Nashville, Tennessee, Evansville, Indiana, Paducah, Kentucky, and Little Rock, Arkansas, with a combined at-risk population estimated at approximately 15 million people spread across 8 different states. It's worth understanding precisely why the U.S. Geological Survey continues to treat this fault system with such sustained institutional seriousness, because it's built on a genuinely rigorous, multidisciplinary body of evidence, not simply historical memory of the 1811-1812 sequence alone. According to the USGS's own official fact sheet on this exact topic, there is broad agreement across the scientific community that a continuing concern exists for a major destructive earthquake within the new Madrid Seismic Zone, an assessment built directly on decades of research conducted by dozens of federal, university, state, and independent consulting earth scientists. Now here's where this story genuinely gets interesting, because it directly involves a real scientific controversy the USGS itself has had to publicly address. According to that same official USGS fact sheet, considerable public interest developed several years ago from media reports specifically suggesting the new Madrid Seismic Zone might actually be shutting down entirely. Those reports stemmed from genuine published scientific research using GPS instruments to measure strain, meaning the gradual buildup of physical stress in the Earth's crust across the region. Because researchers detected a genuine lack of measurable strain at the surface across parts of the seismic zone over a 14-year monitoring period, some scientists advanced the argument that there was no meaningful buildup of stress occurring at depth within the fault system, and that the zone might therefore no longer pose the significant hazard it once did. The USGS's response to that specific argument is genuinely worth understanding in detail, because it reflects exactly the kind of careful, multi-evidence stream scientific reasoning we've discussed throughout our previous coverage of other fault systems. As part of the formal consensus building process used to construct the national seismic hazard maps that inform building codes, across the entire country, the USGS convened a dedicated workshop of expert seismologists specifically to evaluate the latest earthquake hazard findings across the eastern United States. Those experts directly considered the same GPS data showing little to no measurable surface strain. Their conclusion was direct and unambiguous. That data was not found to be a convincing reason to lower the seismic hazard assessment for the new Madrid region, especially given the many other independent types of evidence that inform that broader hazard assessment. It's worth walking through exactly what that other evidence actually consists of, because it's genuinely the strongest, most direct argument for why this fault system continues to be treated as an active, ongoing hazard, despite the absence of easily measurable modern surface strain. Geologists have identified widespread, abundant deposits called sand blows across the region. Sediment features, formed specifically when powerful earthquake shaking causes water-saturated sand deep underground to liquefy and violently erupt up through cracks to the surface, similar to a small, localized geyser. Using radiocarbon dating on organic material found within and around these sand blow deposits, researchers have been able to identify and date previous clusters of large earthquakes that struck this exact same region well before written historical records existed, specifically around AD 1450, AD 900, and 2350 BC. The sizes and geographic distribution of these older, prehistoric sand blows indicate that those earlier earthquake clusters were genuinely similar in scale and severity to the well-documented 1811-1812 sequence. That's direct physical geological evidence of a fault system that has been producing major, repeated earthquake clusters for thousands of years, evidence that exists entirely independent of whatever modern GPS instruments happen to be measuring or not measuring at the surface during any particular 14-year monitoring window. Let's talk about the actual current probability estimates scientists have built from that combined body of evidence, because it's genuinely useful to understand the real quantified numbers, rather than relying purely on vague general concern. According to detailed hazard analysis, scientists estimate the probability of a magnitude 6.0 or larger earthquake occurring within the New Madrid seismic zone during any given 50-year period at somewhere between 25 and 40%. That's a genuinely significant, non-trivial probability for a single fault system over a human lifetime scale window. For the truly catastrophic 1811, 1812 scale events specifically, geological evidence pointing to that recurring pattern of major earthquake clusters, roughly every 300 to 600 years, suggests the region may currently sit somewhere in the early to middle portion of its current seismic cycle, since the last major sequence occurred approximately 214 years ago. It's genuinely important to be precise and honest about what that specific figure does and doesn't mean, because a 300 to 600 year recurrence interval carries an enormous range of uncertainty, one that means the next truly major new. Madrid earthquake could, in principle, occur tomorrow, or it could remain more than a century away. That uncertainty itself is precisely why prediction isn't a realistic or useful framework for engaging with this specific hazard, and why preparedness remains the only genuinely responsible approach available. It's worth understanding what's actually happening within this fault zone right now on an ordinary, day-to-day basis, because the region genuinely isn't seismically silent between major historic events. According to current monitoring data, the New Madrid Seismic Zone continues producing approximately 200 small earthquakes every single year, the overwhelming majority measuring below magnitude 2.0, far too small for anyone to feel without sensitive instrumentation. Occasional magnitude 3 to 4 events do occur and are genuinely felt by residents locally, though without producing significant damage at that specific magnitude range. The USGS, working alongside the Center for Earthquake Research and Information at the University of Memphis, maintains a dense, continuously operating network of seismometers, monitoring this entire zone around the clock, precisely the kind of sustained institutional monitoring infrastructure we've discussed in previous coverage of other seismically significant regions. Now let's talk about why this specific fault system genuinely deserves the description forgotten, because it's not simply a matter of public awareness. It reflects a genuinely serious, well-documented gap in physical infrastructure preparedness, one considerably more troubling than the equivalent gap in most West Coast seismic zones. According to detailed infrastructure vulnerability analysis, California mandates seismic retrofitting for unreinforced masonry buildings and enforces genuinely strict statewide seismic building codes, requirements built up over decades of sustained institutional and political attention to that state's well-known earthquake risk. Across the states covered by the New Madrid Seismic Zone, the picture is described directly as very different. While the modern International Building Code does technically include seismic design provisions for this specific region, enforcement of those provisions varies enormously from jurisdiction to jurisdiction, with many rural areas across the affected states carrying minimal to no meaningful code enforcement at all. More critically still, the existing building stock throughout Memphis, St. Louis, and the smaller communities scattered across this entire zone was overwhelmingly constructed decades before any seismic design provisions existed whatsoever. And unlike California, most states within the New Madrid Seismic Zone maintain no mandatory retrofit programs at all for the specific kind of dangerous, unreinforced masonry buildings that historically prove most vulnerable to collapse during significant earthquake shaking. It's worth understanding exactly what a major, repeat New Madrid earthquake would actually do to this region's critical infrastructure, because the specific vulnerabilities extend well beyond individual buildings. According to detailed risk mapping of the zone, only a handful of bridges cross the Mississippi River between Memphis and St. Louis, and most of those existing bridges carry limited, if any, meaningful seismic design. The loss of those bridges in a major earthquake would effectively split the entire United States transportation network along an east-west line, disrupting an estimated more than $400 billion in annual commerce that depends on that specific transportation corridor. Major petroleum pipelines also cross directly through this seismic zone, and a rupture along those pipelines during significant earthquake shaking could produce fires, environmental contamination, and genuine fuel shortages extending across a significant swath of both the southeast and midwest regions of the country. It's worth pausing to genuinely contrast this specific infrastructure picture against everything we've discussed in previous coverage of West Coast seismic hazards throughout this entire series. California residents, for all the genuine serious risk their state's fault systems carry, live within a regulatory and infrastructure environment that has spent decades and enormous sums of money actively working to reduce exactly the kind of structural vulnerability that historically produces the highest casualty counts during a major earthquake. The New Madrid Seismic Zone, despite carrying a documented, quantified hazard, genuinely comparable in raw seismic terms, and despite affecting a comparable or larger total population, sits within a considerably less prepared built environment. Precisely the combination of genuine geological hazard and comparatively limited structural preparedness that makes this specific fault system's relative public obscurity so genuinely consequential. Let's talk about what genuine, useful preparedness actually looks like for anyone living within this fault zone's reach, because this is precisely where this story becomes practically actionable rather than simply alarming. The USGS's own guidance on this exact point is direct and consistent with everything we've discussed throughout our coverage of other seismic hazards across this series. Since science genuinely cannot predict when the next major New Madrid earthquake will occur, whether that's tomorrow or 3 centuries from now, the only responsible approach is sustained, ongoing preparedness rather than any attempt at prediction. That means maintaining a genuine household emergency kit, stocked with water, food, medications, and basic first aid supplies sufficient for at least several days of potential disruption. It means understanding your household's specific emergency plan, including how family members will communicate with each other if cell networks become overwhelmed in the immediate aftermath of a significant earthquake. For anyone in this region who owns their home, it means genuinely understanding your specific building's seismic vulnerability, particularly if you live in an older structure built before modern seismic design provisions existed, and understanding whether earthquake insurance, a coverage many homeowners across this specific region have never even considered, given the area's relatively low seismic awareness, might be a genuinely worthwhile addition to your existing homeowner's coverage. It's also worth understanding, for anyone in Memphis, St. Louis, Nashville, or any of the other major population centers sitting within this zone's reach, exactly what kind of intensity of shaking a major, repeat New Madrid earthquake could realistically produce. In your specific location, seismologists use what's called the modified Mercalli intensity scale to describe exactly how strongly ground shaking would actually be felt at any given location. A magnitude 7.5 or greater New Madrid rupture would produce concentric rings of decreasing shaking intensity radiating outward from wherever the earthquake's epicenter happened to occur along the roughly 150-mile fault system, meaning your own specific proximity to whichever segment of the fault ultimately ruptures would directly determine how severely your particular community actually experiences that shaking. So, pulling this entire story together, what's the honest, complete, scientifically grounded picture of where the New Madrid Seismic Zone actually stands? Today, this is a genuine, well-documented, actively monitored fault system running directly beneath the central United States, one that produced 3 of the most powerful earthquakes in recorded American history within a single winter, more than 2 centuries ago, and one that continues producing approximately 200 small earthquakes every single year is clear, ongoing. Evidence of continued underlying tectonic activity. Scientists still don't fully understand the precise mechanism causing this specific intraplate fault system to rupture at all, though an ancient failed continental rift zone remains the leading working theory currently under active research. Despite a genuine, publicly debated scientific controversy over whether limited modern GPS strain data might indicate the fault system is quieting down, the U.S. Geological Survey's own official, consensus-based position, built on multiple independent lines of geological evidence spanning thousands of years of prehistoric earthquake activity, remains that this fault system continues to pose a significant, credible hazard to the roughly 15 million people living across the 8 states within its reach. And unlike California's comparatively well-prepared seismic infrastructure, the communities sitting most directly within this fault zone's path carry considerably less structural, regulatory, and public awareness, preparation for exactly the kind of catastrophic event this fault system has already proven itself fully capable of producing, not once, but repeatedly, across thousands of documented years of geological history. For anyone living within Memphis, St. Louis, Nashville, Evansville, Paducah, Little Rock, or any of the smaller communities scattered directly across this fault zone's roughly 150-mile length, the practical guidance drawn directly from the USGS's own consistent, decades-long messaging remains genuinely straightforward. Maintain a real household emergency kit. Know your family's communication and evacuation plan. Understand your own specific building's seismic vulnerability, particularly if you live in an older, unreinforced structure, and treat this specific, genuinely underappreciated seismic hazard with the same seriousness that residents of far more famous, far more publicly discussed fault zones elsewhere in the country have been encouraged to maintain for decades, precisely because, as this fault system's own documented, 1,000-year history makes unmistakably clear, geological silence is never the same thing as geological safety. We'll keep it tracking research and monitoring updates from the new Madrid Seismic Zone as new findings continue to emerge from the scientists studying this genuinely fascinating, genuinely underappreciated American fault system. Subscribe so you don't miss it, and drop a comment letting me know if you live anywhere within reach of this specific zone and whether you'd ever heard of its full historic significance before today. Stay curious, stay prepared, and I'll see you in the next one.